when we last spoke, you guys had practiced synthetic division. So we're going to try it again here. If you guys would, on your paper, synthetically divide this ugly and long polynomial.
Yay! Ugly.
If you need a refresher on synthetic division, I will be working the problem on the board in parallel to you guys, but I'm going to give you a moment to get started. Remember, the first thing you do to set this up, opposite of this guy goes here.
We have to do it that way.
Yeah, you have to do synthetic, because we're going to work with synthetic today. That's how you set it up. If you're lost as to how to do the first step, you bring down this number, multiply, and add.
Up there,
Yep,
when it gets down to like 6, 5, 4, 3, do we have to do like 0, x?
yep.
Okay.
So you fill in a 0 for any terms that are missing. Can you get it set up like this? Okay. Start with that. Don't copy down these three numbers just yet, because those are part of the solution. Hey, Ed. If I could get you to get some paper and pencil.
And my question for today would be how to use synthetic division.
Sure. Go ahead and set up the problem minus these three numbers. That's how you set it up.
Minus what, do you know?
Minus the three I just erased. So get that set up on a sheet of paper.
You can
Yes.
tell me how to do like the first one, then I should be able to.
Absolutely. Let Ed get the numbers copied down, and then I can show both of you guys at the same time how to get it started.
What do we do for 6 and 4?
Remember, it's synthetic. The process is completely different looking. So, guys, what you do here, Ed and Aaron and Bob,
Yes.
you take the first number and pull it down.
Now we're ready.
Done. You just bring the number down. Then you take the number out here and multiply it by this number and carry it up, and I'll use a different color to show you this. The product of those two, -6 times 1 is,
-6.
so you put that there. Same deal again, -6 times 0.
Here.
Now go ahead and carry it all the way through.
And you just sort of repeat this
Yep.
process?
So what does that mean? I mean, right at this point, yeah, sure, we can all memorize a procedure.
Then
Um,
do you divide? that?
Nope, because then you're done. Remember that whole long division thing we did? This replaces it.
How would you simplify that solution?
Yep, so what does this mean? All right, that's a polynomial, there's all these x's in it and whatnot. One moment. The answer is, how many times does x plus 6 go into this whole ugly thing? Is x to the fifth because it's one less than the biggest number over there, plus, there's no fourth term, 2x to the third.
What? Why didn't you just say
Minus
x, 0, x to the 4th?
Well, you could put 0x to the fourth there, I just dropped out all the 0 terms.
Oh,
Okay, with a remainder of
0?
0. Okay.
Because you have to take it off from there.
Yeah, so because we're dividing x into x to the 6th, it goes in x to the 5th times. Or you can just remember that your answer here is always going to be one less than the biggest number here.
Only at the beginning.
Yeah. So this one starts at 5 and then they go down 1 from there. 5 to the 4th, to the 3rd, 2nd, 1st, and then. So there's what a solution looks like. It's a reasonably quick process. Now, why in the world would you ever want to do this? I actually put it out on Facebook Yes, I'm a math geek that bad. I put it out on Facebook that why in the world would you want to do this synthetic division? What's, so what? So I can do a process and I can get some numbers and I can multiply some things. One of my professors from this summer happens to be a friend of mine on Facebook, and she said, why I use it all the time to find eigenvalues, which is like her specialty in math. I mean, it's so far up there, it's math, that if I've had it, I don't recall what it does. It has to do with vectors, is all I know.
Ugh.
So this process really does get used by real honest-to-God mathematicians. But we're going to look at some ways today that it can be used by, mere mortals.